Okay, the B up there means this is going to be brief. So use this for a quick review. Use this for, first run through of the whole idea, if you wish. It might be all you need. So you might not have to look at the more extensive videos. Okay, so we want to look at a tangent line. Now, first thing you know is you can find the equation of a straight line if you know a point on the line and its slope, and right there is a formula, and there's what the formula means. This just says slope from xy, x1, y1 to xy, which is change in y over change in x, equals slope of the line. Rearrange that, you get this, the most common form of the equation of a straight line given the point and a slope and so forth. So we have this formula you very likely know, but you want to think about the reasons. Okay, you want to think about where that formula comes from, what it expresses, and hopefully you already have. Okay, well, that's simple. Okay, you need a point and a slope. Okay, well, now if we have a function y equals f of x, and of course you're given some value of x, okay, and that value has to be in the domain of x, otherwise plugging it in doesn't help. Then you can get a point on the graph. Just by plugging x naught in here, you get the y value. So your x coordinate of the point is x naught, your y value is f of x naught. And then if x is also, if f of x is also differentiable at this value of x, you can find its derivative. What's its derivative tell you? The derivative is identified with the limiting value of the difference quotient. Any difference quotient is can be represented as a slope on the graph of a function, and the limiting value is the slope at the tangent line. And hopefully you understand all that. If not, well, at least for now, you do want to understand that, but just for now you should know that the derivative at a point x naught gives you the slope of the tangent line at the corresponding point of the graph. Assuming, of course, the function is differentiable so that you can find f prime of x naught, so that f prime of x naught even exists. Okay. Then, what do you know? You got the coordinates of a point, you got a slope. Well, translate that into a tangent line very easily. Okay, so how do you do that? Well, here's an example. Let's find the equation of a tangent line for f of x equals x squared when x equals 3/4. Okay, well, if x equals 3/4, then f of x equals 3/4 squared, which is 9/16. Here's a graph. You ought to know how to graph y equals x squared. You know, at least get a schematic of the graph. It's not an accurate graph, but it shows us what's going on. Okay, so we've got, excuse me, x coordinate 3/4. Y coordinate has to be 9/16. Right there's the point, 3/4, 9/16. Right here's the tangent line. Slope of the tangent line is what? It's the derivative evaluated at 3/4. Now, what's the derivative of our function? Well, derivative of f of x equals x squared is f prime of x equals 2x. You should know that. If you don't, you probably ought to back up and make sure you know how to do the few basic derivatives. Okay, so that f prime of 3/4 turns out to be 3/2. So now what do we know? Tangent line goes through x1, y1 equals 3/4, 9/16, meaning x1 is 3/4, y1 is 9/16. Slope is 3/2. We just plug that into this form, and this is what we get. Here's your y1, here's your x1, here's your m. Boom, there's the equation. Now we can solve that for y and get the slope-intercept form. More generally, if your point on the graph, as we've said here, is x naught f of x naught, and the slope is, as we said, f prime of x naught, then what do we get here? Well, this is the x coordinate, this is the y coordinate. In this form, we'd say x1 is equal to this x naught. That's okay, subscript doesn't matter. We could change these subscripts to zeros if we wanted to. You're going to get x minus x naught, which you have here. You're going to have a y minus the y naught, or y1, which is the y coordinate of the known point, which is f of x naught. And you're going to have the slope, which is f prime of x naught. Right there it is. Okay, so this is just this equation where we use these for the coordinates of our x1, y1 point, and this for our slope. Now this equation rearranges. I ran out of room, so I wrote it up here. y equals f of x naught plus f prime of x naught times x minus x naught. It's a very intuitive equation, as we're going to see, but you see how this easily rearranges from here. We just add x naught, f of x naught to both sides, and we get this. Okay, so we'll go on with this.